All right, we're going to go ahead and get started. Thanks everybody for tuning in. I know we'll have a bunch more people join just a minute into our start time, but really appreciate everybody joining. My name is Chris Neidel. I am one of the co-founders of the Open Air Collective, and I am the carbon removal lead for the UN Climate Champions. And for many, many years, I have been working on the decarbonization of concrete through policy advocacy at the local and state level. Normally based in Texas, although I'm a New Yorker. Right now I'm in Brussels, which is a long story, but really pleased that everybody could join us today. And what we're going to do for our agenda, I'll just go through that real quickly. As it says on the title there, this is a workshop, and this is meant to be very practical to talk about what it means to implement a low carbon concrete building code in your city. And we have some amazing experts to talk us through that, who I'll introduce in just a second. But what we'll do is I'm going to just quickly spend probably about 4 minutes going over some key concepts that I think will help get those out of the way for people that are completely new. And then we're going to be very lucky to have Professor Matt Adams is going to give a presentation, first talking a little bit about what, in practical terms, low carbon concrete even is. So what are we trying to achieve here? And then critically, which is really at the center of our discussion today, he's going to go over a new building code amendment that's been developed that he actually led the development on with many other engineering professionals at the American Concrete Institute, called ACI Code 232. And this is actually gives guidelines for how jurisdictions, whether it's counties, cities, states, can implement a building code that encourages the use of low carbon concrete. And then we're going to spend most of the time in a discussion and Q&A at the exact same time. So I'll be talking to our panel, asking them some questions. But as your questions come in, you use the comment bar for that on the right-hand side of your screen. We're going to go ahead and pull those right in. And that's really the main point of this workshop, I should say, is really addressing folks' question. Now, who are all of you? We advertise this to basically anybody interested in the subject. This is certainly designed for folks who work within city, county, or even state government, in sustainability departments, in departments of building and code councils, who are looking at this as a subject of interest, and they want to learn more about how it might be implemented in their city. But it's also absolutely of interest of citizens, activists, volunteer, professional, who are in their place and they have heard about this subject and they want to see what they can do to actually potentially help bring this to the attention of their city, county, or state in which they live in. So who we have today, Brian might be on already. I'll let him in 1 second, but we have an amazing panel of folks who have a lot of expertise, practical expertise in this subject and kind of live it every day. Professor Matthew Adams, who you're going to hear from in just a minute, he's going to give us our presentation. Is a longtime collaborator of mine. We've worked together for, I don't know, Matt, probably going back 4 years at this point. He has many different roles, including is really the chair of the relevant committee that developed this code at the American Concrete Institute, which I'll tell you a little bit about. He's also an associate professor at NJIT, and he runs a lab there focused on sustainable cement and concrete. Kerry Sutton is a senior director at ACI as well. Also an engineer, and is really responsible for educating, outreach, and trying to get this code implemented. So we're going to hear a little bit. She will weigh in on some of the technical aspects along with Matt, but can really sort of talk about the steps that are involved in actually implementing a code. And then we're really thrilled to have Brian Reyes, who's the senior circular economy coordinator for the city of San Francisco's environment department. But prior to that, he was actually one of the key figures who was involved in developing a predecessor program, the first in the country, that Marin County, California, actually came out with, I believe, back in 2019, that was the first to actually introduce low embodied carbon concrete in the building code. And so he can tell us a little bit about the process of that, but with some years in hindsight, can also tell us a little bit about what has been learned. And then also in his current position in San Francisco, some of the questions about what are some of the barriers potentially that cities might face as they consider implementing such a code. So really happy to have all of them. You'll meet them shortly. So as I said, I want to go over just some high-level concepts, particularly for folks that are new to the concept or the subject. We're talking about concrete decarbonization, or lowering the carbon content of concrete. Why does that matter? Concrete's the most used building material on Earth, most used material after water, second only to water on Earth. Comes in many different forms that we've all encountered, whether we know it or not. It's ubiquitous. And one of the things that's really interesting, which I think links this to local efficacy and local leadership, is that most concrete has to be made local for different reasons. So you have concrete production in your midst, wherever you are, city or county. And because of that, that gives a special role at the local for actually implementing new interventions, such as the ones we're going to be talking about today, to start having an impact. Concrete is a really simple material. Matt will probably go into it a little bit more, but it's basically a bunch of sand and gravel that we call aggregate mixed with some water, and then cement. I know Matt will tell us that there are some other bits and bobs in there as well, but those are the main parts. The cement is the very critical material that's the binding agent that kind of pulls it all together, and really to which its hardening ability and its strength abilities can be mostly attributed. It's also the key part of the discussion when we talk about the impact of concrete from a climate perspective. Cement, if it was its own country, it would be the third largest emitter in the world. It accounts for about 8% of emissions. And it's about, depending on the mix, some have more cement than others, but if you take an average, about 90% of the carbon emissions that are associated with concrete trace back just to that one ingredient, cement, which often is relatively small proportionally relative to those other ingredients. A couple of concepts that we're going to be talking about that are important. There won't be many of them, but one is embodied carbon. So some people might, when they think of carbon emissions, they think of smoke coming out of a tailpipe or out of a smokestack, and associate it with using things that use energy. That's called operational carbon. Here we're talking about embodied carbon, and with materials like steel and asphalt and glass and concrete, the emissions associated with them are not in their use, but rather at how they're made. And so that's the carbon that's sort of embodied in the process of actually making the concrete before it's actually laid. And then related to that, ways in which we measure embodied carbon, which we'll be talking about, GWP, or global warming potential. This is a numeric value that basically equates to the cubic yards of carbon or kilograms per carbon per cubic yard of concrete. And this is a number that we use to sort of rate all sorts of materials and products, but certainly for concrete, a higher GWP means there's more embodied carbon, and a lower one means, and that's what we use sort of as our tool of measuring progress or compliance. Quick thing here, in terms of what we're talking about, are what are the ways in which local governments can be linked to decarbonization? What types of policies or programs or practices can they play the biggest impact? Certainly procurement is one that I've worked on a lot. Governments, local, state, and national, buy a lot of concrete for public infrastructure, buildings, bridges, et cetera. And somewhere up almost over 30% of all concrete is purchased and used by the public sector. So the governments of all kinds have power in the way they procure concrete. They might mandate that there's a certain GWP or embodied carbon threshold that they reach, or incentivize producers to pursue lower mixes or lower varieties for state work. And we'll talk about that in some future date. It's a really, really important, very active area of concrete decarbonization policy. But what we're going to talk about today is more broadly in the neighborhood of different regulations, right? And so cities and states often play a really important role in evaluating materials and approving them, those that can actually be used. But the one we're going to be talking about today is the regulation of building codes, how buildings must be built, which has many different facets to it, but concrete is right there. And what we're going to be talking about today is how building codes, the parts that pertain to concrete, can actually now include limits to global warming potential or carbon. And that is the subject of today's conversation. And to spell it out a little bit, what we're talking about that, and there's different varieties of it, and we're going to focus particularly on the ACI code that came out in November. But the idea there is that in buildings of different sizes, different construction projects that use concrete, within the building code, they establish that there's a kind of a maximum threshold for global warming potential that must be met as part of the building process. And so that's what we will be talking about today. And it's important to point out, for those of you who are in California or Colorado and maybe soon to be New York City, which has a bill pending right now that would add maximum embodied carbon to a host of different building materials, including concrete. These other programs like CalGreen and the soon to be implemented Model Green Code in Colorado, they're not exactly the same, but they have similar enough designs where I think what we discussed today, some of the practicalities of implementation, will be relevant to you as well if you're in either of those two states. But again, what we're going to do, and I'm going to hand it over to my friend and our guest today, Professor Matthew Adams, and he's going to talk first again about defining a little bit in practical material terms what low embodied carbon concrete or low carbon concrete is, which is really important when you're thinking, well, what are we asking of builders in our city if we were to implement such a code? And then he's going to get into what the code actually calls for and what is contained within it. And then after that, as I mentioned, we are going to get right into a discussion that will include you. So please do use that comment section. Let me go ahead and remove that. I'm going to go ahead and bring up Matt. Brian, I see you there. Don't worry, buddy. We'll bring you up after Matt's conversation. Hey, Matt, how you doing? Good to see you again, my friend. Thanks so much for joining us.
Good to see you. No, happy to be here. Thanks for having me.
Great. So do you want to tee up a little bit? I'm going to pull your presentation up.
Sure. So, first, just to kind of explain why I'm the right person to be here talking about this. So my background is in concrete materials. I have a PhD in civil engineering from Oregon State University. And all of my research focuses on advanced concrete materials, novel concrete materials, with a special focus on low carbon or sustainable materials for use in construction. Around 2019, 2020, I also started to get involved with the policy side of this work, trying to understand what all the barriers are to implementing some of the newer technologies that are out there. And through that process, I've sort of become one of the leaders in the country on how to actually implement new concrete materials, and in particular, how do we overcome some of the barriers that are out there in terms of laws and building codes, et cetera. In 2023, the American Concrete Institute asked me to lead an effort to publish a model building code for requiring low carbon concrete. We put together a really great team of experts from really around the world to look at this and to develop model building language. And in the past year, I've been going around talking about this code. We were able to publish it last November. So we put it out in less than 18 months from our first meeting, which is probably record speed for a building code. But I'm here to talk about this. I'm not going to get in depth on anything too much. Chris asked me to be kind of quick, but if you are interested in more information, you can look up my name and concrete on YouTube, and there are many presentations on this that have been recorded, some by Open Air and Blockheads, that you can dive deeper into some of these items. Let's see, how do I advance this? Okay, so Chris went over this a little bit already. Why do we need low carbon concrete? Concrete production is responsible for around 7 to 8% of global CO2 emissions. The reality is that in North America and Europe, that number is closer to about 1.5%. The issue here is that we have other sources of CO2 that we're producing at a greater scale, and also we're not constructing nearly as much as some other countries such as India or Brazil or lots of places in Africa. Despite that, we can still do better. We can reduce our carbon production associated with concrete, and a lot of the technologies and methods that we develop end up getting exported out to other places around the world. And we're also importing ideas from around the world as well. So this is really a collective effort of researchers and policy folks from around the world that we're working to bring in some of the best ideas. So what is low carbon concrete? Low carbon concrete is a term you've probably heard if you're here before. Until the code, there really wasn't a set definition for what low carbon concrete is. In reality, it's a performance requirement that is set by your licensed design professional or your LDP, and it's based on reducing your global warming potential below a threshold. So in order to do that, you have to define a benchmark. So you have to set your threshold of where you are in terms of GWP, and you need to define a reduction level. So once you hit that reduction level, you have what is called low carbon concrete. This number can vary because what is low is relative to your particular location. As Chris mentioned, concrete is somewhat necessarily a local material. So the tools that we have to make concrete in one part of the world or one part of the country are different than in other parts. I'll talk in a second about some of the different components, but really concrete can vary quite a bit from location to location. And so what is considered lower carbon systems in, say, New York City may not be possible to be made in a place in certain parts of North Dakota or northern Canada, for example. So how do we get to low carbon concrete? Like I said, it's a design goal. There are lots of levers and knobs that we can simultaneously use to reduce embodied carbon. Much of this is going to be subject to local availability and cost. And so, like I said, what is available in your local area? So working with your local manufacturers is really important. And when we're changing from standard practice systems to newer systems, they really require knowledgeable folks along the entire construction chain, right? So not just the engineers designing it, but our contractors, our suppliers, all of our laborers that are out there placing the concrete. Everybody needs to understand some of the differences. If we think about concrete as a cookie, right? You have your regular chocolate chip cookie, and we can think of concrete in that way. In a chocolate chip cookie, you've got eggs, flour, and butter. These are our glue or our binder that hold everything together, similar to concrete where we have cement and water. When cement mixes with water, or Portland cement mixes with water, it does this process we call hydration, and it glues everything together. It hardens up and it glues everything together. In our cookies, we have filler and flavor. These are sugar and chocolate chips. In concrete, that's sand and gravel. We use as much sand and gravel as we can because it's cheaper than cement, and it also has lower embodied carbon. And then we have modifiers such as our baking powder and baking soda in cookies. In concrete, we use a lot of chemical admixtures and perhaps some mineral admixtures. These will help change some of the properties. Like a chocolate chip cookie, though, there isn't just one way to make concrete. We can change out all of our filler and flavor. We can change out the types of binder ingredients that we use. There are lots of different tools out there that we can use. And by making some of those changes, we can start to see reductions in carbon emissions. Sorry, I lost an image on here. It went away. But basically, this image should show a bag of cement, and it should say lower carbon binder systems is one way, right? There are many different types of binders that we can use outside of just straight Portland cement. And these can have lower embodied carbon. These might include replacing part of the cement with waste materials like fly ash, which is a waste product from coal burning, or slag, or ground glass. This can involve complete replacement of the binder with something else. We see this in what are called alkali activated systems or geopolymers. We see other types of materials like calcined clays. Biochar is starting to get a lot of attention lately. So that's one way that we can do that, by replacing that high emitting cement with materials that emit less or are waste products. We can also work on reducing the overall binder content, so reducing the total amount of cementing materials that we have. We do that by increasing our aggregate content. That requires some engineering of our aggregates to understand how they all fit together. But the more we can get the aggregates packed into the system, the less glue we need to hold them together. And then finally, we can start to use more recycled materials in concrete. So things like recycled aggregates, recycled glass, recycled plastics, et cetera. These are all being studied for use in concrete. There are items that are further along the use scale than others. I do want to point out that you do need to be careful, though. There are a lot of folks out there selling carbon negative or carbon zero products that are magically going to reduce the carbon in concrete. These all come with pros and cons, right? They all are going to change some of the properties of concrete, whether that's the properties when it's being placed, how fast it sets, how fast the bleed water sets. You really have to understand that before you go and use them. And then also some of them are not able to actually be made at scale yet. We make a lot of concrete. In the US alone, we make over 400 million cubic yards, which is enough to make over 300 Hoover dams a year, right? So we make a lot of concrete. A producer is not going to use a new material if they can't be certain that they're going to have a regular and steady supply of that material. So those are some of the pitfalls with new materials, but we do have a lot of viable solutions that are already used in practice and well understood. So moving to lower carbon concrete is not actually all that difficult for us. Getting to zero carbon concrete is another question. That is something that we don't really have the technical capabilities to do yet on a wide scale, but we're working on it. So why do we need a code? Why do we need this building code? Chris talked about all of these policies that are already being developed. If you're here, you might be familiar with some of them. This image from National Ready Mix Concrete Association shows some of the places in the US where there's state level action happening. And even this is from 3 months ago and it's already out of date. The issue is that a lot of these policies are great, but they're all being developed independently of each other. And so there's a lot of variation in methodology. And most of them are requiring what we call prescriptive limitations. So they're really stifling innovation and flexibility within concrete design. And additionally, some policies are being proposed that list really unrealistic or unattainable long-term goals. Like I said in the last slide, we don't really have a method of getting to zero carbon yet. Net carbon is a different question in terms of buying offsets. That's sort of outside of my realm of expertise into whether offsets work or not. But we don't have the tools in place to get to zero right now. And so we're seeing policies that are being proposed that are saying that by 2040 or 2050, we're going to get down to zero carbon associated with concrete. We want to be really careful about policies like that, because when we input policies that are not attainable, they end up just getting ignored. So we want to move forward with unrealistic or with realistic and attainable policies. So this led us to developing this code. The need for it was out there as we're seeing people trying to work on how to get to this, how to set requirements. This code is the first of its kind in terms of model building codes worldwide. It followed a consensus process, meaning that we had a group of people that had to come together, had to agree on the best practices. We then, once we had the approval within the American Concrete Institute, it went out for public comment. And during that consensus process, we have to not just look at every public comment that comes in, but we have to respond to every comment that comes in, right? So we can't just look at it and ignore them. We need to have a response. This code provides designers with a method of setting GWP requirements for concrete associated with their project. Currently, the code only applies to ready-mix concrete within a strength range of about 2,500 PSI to 8,000 PSI. We're looking to expand that. Hopefully, we will include precast in the next round. The reason why we were limited was, one, we limited the scope to get something out quickly because the need was there. And two, there's a real data issue in terms of setting benchmarks and thresholds. We don't have a lot of widely available data on the global warming potential of concrete that's currently used and really project-specific global warming potentials. There's lots of great industry-wide and national averages out there, but that's not really good data in terms of getting a realistic picture of what's out there. Sorry, I should have deleted those. There are three main ways that we see limits being set for carbon emissions with concrete. One is called what we call carbon limits. A second is a carbon budget, and a third is a weighted carbon budget. A carbon limit sets a global warming potential limit for each class of material, meaning on a regular concrete project, you can use 10 to 15 to 20 different concrete mixes. Each one of those mixes will be required to be below a specific GWP threshold. Those limits are easy to set, but they reduce flexibility in design, and often they can lead to increased volumes, right? Generally, we assume that the higher the strength of a concrete, the higher the GWP. And so what we see when we say that all concrete has to be below a certain threshold, what we see is that people just increase the amount of concrete that they're using to offset having to use a slightly lower strength. This area is really where most of the policies nationwide are right now. Again, it's a good first effort because it's fairly easy to access. It's easy to get some data to set this, but it does lead to low flexibility. The next system that we see are what we call carbon budget systems. These are going to set a GWP limit for an entire system. So you can use some concrete mixes that are high GWP and some that are low, as long as your total global warming potential is less than your budget. However, for this, it's really difficult to set benchmarks because each building is a different size, each different types of projects have different requirements. And it really only works best for whole building analysis. When we're looking at material-specific items, it doesn't work that well. Right now, we are focused on material-specific applications. We're moving towards whole building analysis and getting that standardized, but we're just not there yet in terms of having the right standards in place. This is something that, unfortunately, we can't do through a group like the American Concrete Institute. At the American Concrete Institute, we can only consider concrete. We're really kind of stuck within that scope, which is great. But we need an organization like, say, the American Society of Civil Engineers to then pull together information from all of the different materials to set a full carbon budget. The code that we're talking about today uses what's called a weighted carbon budget system. So this system sets a weighted volume or a weighted GWP limit based on the volume of each class of concrete used. So for each type of concrete mixture you have, you're going to measure the volume and the GWP associated with it. This system gets to be highly flexible in terms of design because in some parts of your construction, you may have a need for a high strength concrete or something that sets really quickly. Those tend to have higher GWPs. And so if you need that, you can use that in specific places and offset the higher GWP of those mixtures with systems that have lower GWP in, say, like a foundation where it's really easy to get low GWP. And so this tool is a lot more flexible than what's out there, and really we worked hard in our committee to develop the right guidelines for this. This really comes out of having concrete engineers and designers developing the policy language rather than folks that are not quite as focused on how the material works. So just an overview of the process. Again, I'm not going to get too in depth on this. There's a number of YouTube videos out there where I really dive into the code. But for the code, you're going to choose a type of project that you're doing. So it could be a building, a pavement, a bridge. And we look at the entire project that is being bid out. So if you're building an entire community of homes and that's one project, you would include all of the concrete within that community of homes. It really, how you define a project is set in some of the guidance in the code there. You then are going to choose a compliance path, and that's based off of the size of your project. And we have 3 different paths. So the highest path for the largest projects, you're going to have to limit your GWP below a certain benchmark. This is done so that we're really only taxing is probably the wrong word, but putting costs associated with implementing this on projects that can bear the brunt of that cost right now. This is a new process. It takes time for people to learn how to do it. Time costs money in terms of engineering. And so we don't want to overburden smaller projects because it's going to make it harder for the code to get adopted that way. Our second level, which is mid-range projects, we ask people to submit all of the documentation associated with it, but you're not actually required to meet any benchmark. And the third level is for the smallest projects. And right now, the code does not actually require you to do any action at all. And that is really so that somebody that's building a new concrete pad for a shed in their backyard is not required to go through all the paperwork associated with this. Once this becomes standard practice and concrete producers have all of the right paperwork put together, all of the right systems are in place, then we can increase the requirements. But we don't want these difficulties to be a barrier to acceptance of the code. So once we get future versions of this code, we'll likely see this change. So with that, I'm going to end there. I know that there's probably lots of questions. This doesn't answer everything, but we're going to answer some more questions throughout the next part. Chris, if you want to come back in, we're ready to go.
I'll bring Brian up too, and let me turn your presentation off. Hey, Brian, how are you? Thanks so much for joining. Appreciate it. Great. And I'll bring Judy up too, who's going to help us with some of our questions that come in. So that was great. Really, really good grounding there, Matt. And I did have some questions to kind of start us off with. And one is, I think I'll start with Carrie, actually, because Carrie, it's kind of your, anything you also want to add in terms of how the description of the code, give you the floor for that. But, what has it been about? Anything you also want to add in terms of how the description of the code, give you the floor for that. But, can you hear me?
Little feedback.
Add in terms of how the description of the code, give you the floor for that. But, can you hear me?
Little feedback.
Give me 1 second, guys.
Little feedback.
This is Giselle. Okay. Wait 1 second. I've never had this happen before. Okay.
He was on an infinite loop there.
So while Chris fixes that, Carrie, why don't you talk a little bit about how the code might be able to be implemented and how ACI can help?
Yeah, thanks, Matt. And Matt, you did a great job just giving a overview of the code itself. So just briefly, my name is Carrie Sutton. I'm a code advocacy engineer with the American Concrete Institute. And ACI has this code 323 that Matt just explained, but we have dozens of codes, over 35 codes, over standards, specifications. We do a lot of documents. That's what we do, American Concrete Institute. And but we're really excited about this this code. And just to emphasize what Matt said about the process, it is a consensus process, an approved consensus process to develop this code, which means many folks were brought together to develop it in a balanced committee. So a lot of different folks will, participated in that. And there was the public process. All of our standards at ACI go through a public process and comments that are received. So you get a lot of input and feedback, I think, which is a great way of developing a standard. And Matt kind of alluded to, there's other ones out there. A lot of times some of those standards are being developed by different groups, but the ACI process is a consensus-based process. So I just wanted to kind of clarify that and make that point. So Matt described the code. What we're trying to do here is really look at ways that we can work with authorities having jurisdiction, cities, states who are looking at, adopting or putting in place a code that would address embodied carbon with concrete. So not everything is a one fit everything. Matt kind of alluded to this. Concrete is a very regional product. The materials that make concrete are regional products. So I guess the kind of just to go on that theme is it's something that really, I think locally and state level, it really has to be looked at individually to make the needs and the industry's needs as well, something achievable that everybody can get their arms around. So I'll just leave it at that, and then we'll kind of go from there.
Hopefully I don't have a everywhere all at
Nope.
once. Can you guys hear me okay?
Yeah, that sounds
Okay,
good.
great. I cannot explain what that was all about, but I'm back. Carrie, could you tell us a little bit about, this is since last November, not that long ago, what is the sort of state of, not necessarily acceptance or adoption, because I know this takes some time, but what kind of airing is this getting? Are you seeing actually some early adopters implement?
Yeah, so this, since it came out in the fall, we've been doing a lot of education. So as Matt mentioned, he's been traveling around, and we've been working a lot with different groups, Society of Professional Engineers, and the Structural Engineers Associations. These are the folks that implement the codes on a daily basis. So education has been key, as well as building officials. We've done some webinars with building officials to let them know what this standard is. So the education process is been very in full the last several months. As far as adoption goes, specifically of this code, we do have some agencies that have been looking at this. With code adoption, it's cyclical, right? So people are going to adopt and update their codes on a certain timeline. So it's not like you can just throw it out there and everybody will just grab it right away. It really kind of has to do with when their codes are being updated. And that's really when we can come in and work with a jurisdiction and offer this code if it's something they want to address. So it's a lot of education right now. Implementation, we hope we can see coming up here as cycles, jurisdictions start updating their standards. We have introduced this to as a standard in the International Green Construction Code, the IGCC. They're currently right now reviewing and updating their standard through the ASHRAE 189.1 committee. And we're hoping we can make some leeway there with getting the standard directly referenced in that International Green Construction Code. That's really a model code which can be adopted by anyone internationally as well. So for us, that's kind of where we've been doing a lot of our work at this point in time. But that's basically the
perhaps I should
where
take
we are.
one
Yeah,
quick second and just sort of explain how codes work if you're not really familiar, right? So 323 is what is known as a model building code. We wrote it, it's been approved, it's out there, but just because it's out there doesn't mean that you have to follow it right now. Codes have to be adopted by a particular jurisdiction before they become law, right? And so once a code is adopted, then following it becomes law. And so you may be familiar with something like the IBC, the International Building Code. The IBC is actually, it's a collection of model building codes that are selected through a process similar to what Carrie was just talking about with the Green Building Code. That is sort of considered best practice codes for doing design, right? And so a lot of places will just adopt the IBC. But you can also adopt individual model codes, and you can also make changes to them. So if you don't agree with all aspects of a code, you can a jurisdiction can say, well, we're going to take this but XYZ, right? So there's a lot of flexibility when it comes to actually adopting a code, and there's sort of a number of pathways to get things through. And so even if our code does not get into IBC or IGCC right away, if you're working within a jurisdiction that controls its own code and you're looking to advocate for this, they can adopt 323. They can adopt parts of 323, and Carrie can speak with the people in those areas to help them figure out how to do it if there's a real desire to move forward with implementing low carbon concrete as a code measure.
A lot of very specific questions I want to ask you. Again, folks, please do.
With people in those areas to help them figure out how to do it. If
never happened before.
A real desire to move forward with.
Matt, if you turn your volume off there, it might. There we go. Very specific questions I want to ask you. Again, folks, please do.
With people in those areas to help them figure out how to do it. If
never happened before.
A real desire to move forward with.
Matt, if you turn your volume off there, it might. There we go. Very specific questions I want to ask you. Again, folks, please do.
People in those areas to help.
I'm going to jump off. And give me 1 second. I'm going to jump off and come back on.
Turn your volume off there. There we go. Very specific questions I want to ask you. Again, folks, please do.
People in those areas to help.
I'm going to jump off. And give me 1 second. I'm going to jump off and come back
So-
on.
Turn your volume off there. There we go. Very specific questions I want to ask you.
Interesting.
Again, folks, please do. People in those areas to help.
I'm going to jump off.
So,
I'm going to jump off.
Carrie, Carrie, can you hear me?
Yes, I can hear you, Judy.
So, Sue and I had
Interesting.
Sue and I had a similar question. So, Carrie, can you hear me?
Yes, I can hear you, Judy.
Sue and I had
Interesting.
Sue and I had a similar question. It keeps repeating me. A question
Chris?
is,
Yes, I can hear you, Judy.
will states prohibit counties and municipalities from having their own codes? It keeps repeating me.
Yeah, I don't know how to address this issue, but it seems to kind of come and go. So
Oh,
we're going to do
okay.
the best we can.
Yeah.
I'm not sure if a question was.
Yeah. So, Judy, the question it was regarding can local jurisdictions adopt regarding that?
I don't know how to
Where-
address this issue, but it seems to kind of come and go. So
Oh,
we're
no.
gonna do the best we can.
Yes.
The question is,
I'm not sure if a
states,
question was.
Yeah. So, Judy, the
prohibiting-
question it was regarding can local
can,
jurisdictions adopt regarding that.
And
How to,
how many states are prohibiting local governments from
Yes.
The
adopting?
States?
Yeah, so Judy, the question,
Wow, I don't know.
jurisdiction.
I'm going to go off too.
Yeah, that's a tough one there. I literally am at a loss for how to address that. Right now, it is relatively quiet. Hopefully, Brian can rejoin because I did want to ask him a question.
Yeah.
Here's Matt, it's a mystery. It's strange. It sounds like
Okay.
it's recording our voices, not just feedback. If I might, real quick, I do want to get to Brian real quick. Let's try to get him out here because I think this is important. Brian, thanks for bearing with us as well as the audience here with our weird technical issue. So, Brian, why we were so excited to have you join us was because while what Marin County did is not exactly the same, it is what ACI did. It was a critical first of kind precedent that has a definite family resemblance to it. And so I wanted to sort of, because we have now the benefit of some hindsight in years that have passed, I wonder if you could give us a little bit of background first on what the Marin Low Carbon Concrete Code was and what we know about how successful it's, or some of the issues that maybe are associated with its, its implementation, or if there's been any modifications to its design. The gremlins are honest today. All right. Well, Brian's got a squirrel ball. All right.
Maybe what I can just pose the question that I was trying to. It's a simple one.
Sure.
We can do this at the state, the local, and the county and the municipal level, but some states are forbidding local jurisdictions to adopt their own codes. Now, New Hampshire is just passing this now. It's not to prohibit, advances. It's to actually help the building industry, saying we don't want our builders to have to go to different counties and follow different rules. But unfortunately, our state is so far behind in its code that we're frustrated. And I know Tiffany had a few examples of other states that were moving this way or already had. And Sue on this call had a question as well. So can you comment on that?
Yeah, so as far as I'm not aware of prohibiting the use of it in states, but states are set up, everybody's different in how they adopt their codes, right? They're all on different cycles. They're all have different jurisdiction limits based on how the state is legislated to adopt codes. So in general, a state could adopt, but a local ordinance or a city could also take this code and reference it directly within their city ordinance. And I think this is what Matt kind of alluded to, where some states, all states, well, not all of them, most of them adopt a model type code, a building code, a residential code, an electrical code. And maybe in some cases they're saying they're prohibiting it because they don't have a place for it to adopt it. But that being the case, a local jurisdiction, if they have the authority to adopt and to modify their ordinance, they could directly reference this standard, and it would not be, you just have to look at the language of your ordinance or your local law and see where it best fits. So
you can also, there's a difference between, building code applies to every piece of construction, right, including private construction, but cities can require something like 323 be used for anything that uses city tax dollars, right? And so that's a policy requirement rather than a code implementation. And so there are ways to have it be implemented in certain applications that is not quite as broad as putting it into the code. And we actually see a lot of the initial policy adoption is for state or city funded projects and not for private projects.
All right, where you might be on borrowed time here before the gremlin comes back, but right now things are relatively clear. Again, thanks everybody for bearing with us on the technical issue. There are a couple of key questions, and I will see if Brian is available in a second. One, though, I did want to, which I think is important, and it links back to your presentation, Matt. I think that one of the barriers that might exist for acceptance of this or entertaining this at the local level is a sort of a fear of change in materials and cost escalation that might come from it. Now, what you described in your presentation was a series of things that were decidedly unfancy. And in fact, you were sort of cautioning us not to all go towards the bright, shiny object of the really fancy things. And I wonder, Carrie, this might even be a question that's better for you to answer. How easy is it for a locality in most regions of the country for builders to attain that number with off-the-shelf methods that are well understood and don't come at a premium? I think that's probably one of the top questions.
Well, I guess I would respond kind of what Matt mentioned in his presentation is it's very local. It's very regional, right? I think in some areas, materials, low carbon materials that help supplement and allow those mixes to become very low carbon. It varies. It varies across the country. It varies within a state as well. So it's attainable, but I think it's very local as well. And I think that's the caution here is a blanket type of standard or something adopted. It's very difficult. Like Marin County, I believe, if Brian was on here, would say they worked a lot with their local ready mix suppliers and folks in the area to hone in on that code. To take that code then and place it in New York State probably might not make sense, right? And that's the caution I think that Matt was kind of alluding to as well. Is this code 323 is a basic framework that then whoever adopts this, whether it be a city or a local jurisdiction, has to do a little work to look at what the supply and what the materials in their area are like and what that opportunity is. So as far as that, that's why it is important that that those involved locally have some voice to make sure it's attainable, right? We want to make sure it's attainable, and in the end. So,
yeah, absolutely. Brian just messaged me and said he's only on audio, so we won't see his face. But Brian, if we could just, again, I think that the value of, now 6 years in the books in Marin, and then Marin clearly influenced the CalGreen program. I didn't know if there's anything you could tell us that would be useful for folks on this call that would be interested in adopting either CalGreen or the ACI code if they're outside of California. What kinds of major sort of lessons have been learned or program changes have sort of arisen in the Marin context? Hey, Brian. We see you're off mute. Okay, let's go. Go ahead, Judy.
Well, Sarah has a question. I'm not sure what jurisdiction she's from, but she wanted to know how cities might provide incentives to developers to move to early adoption of lower carbon concrete without having the code in place. And I know we've had some success in this before the code was around. So maybe somebody can comment on that.
Sure. I mean, there's there's a lot of power to go with just sort of public pressure and getting folks to incorporate sustainability into their systems. We see some of these massive corporations that are moving towards zero carbon systems. They want you to seem like it's an altruistic thing, but if it was, they wouldn't be doing so much marketing on it, right? And so there's a lot of social value and capital associated in certain parts of this country with moving towards lower carbon systems. And so the more public pressure that's put on both public and private groups that are funding construction to move this way, that's really important, right? And so you can do that outside of a code. And again, individual policies within cities and towns can help support that. And they can still use something like 323 as the guideline for how to approach that without actually ever saying it's a code, right? So there's those methods, and that's essentially what the policies that are already in place have done without 323 being available. But they basically wrote what are essentially building code requirements into legal policy without actually having it become a part of the building code.
Mm-hmm.
Yeah. Maybe we just in our limited time here, and what this is a recording. What I am certainly going to do is edit this recording before sending it out to anybody. Normally it auto-generates a link, but there was a lot of great discussion that we did manage to have in spite of the technical challenges. But I think, Carrie, I sense that a lot of the folks who have joined today are probably people that are interested in the subject and are of the category of people that would like to see this happen, even if they're not a decision maker. And I didn't know if, almost like sort of shadowing or inspired by your own approach, if you have any recommendations for if someone living in a particular jurisdiction wanted to get this into the bloodstream and maybe try to advance or bring some attention to it, where would they start?
So locally, cities have departments, building code committees, or a sustainability focus, a department that addresses sustainability or recycling or whatever. And I imagine some might have committees looking at how they can address this topic within their city. And I would say bring a copy of the standard of the code and bring to a meeting if there's a discussion on, how do we lower embodied carbon in our construction process in X city, and just say, hey, we would like to try to do this. And concrete's one way. There's other building materials, obviously, but the nice thing is this ACI 323, it's already done, right? It's something they can take and look at and kind of build a policy or look at how they want to implement a program and include it, if they want to do that. So it could be done, again, as Matt said, through a policy that goes into an ordinance. It could be done through, maybe there's guidance in that community, a guidance document. I worked on a guidance document in Michigan with a major city, and easily they could have referenced, it was a few years back, they can reference this standard as in their guidelines. So bringing it to the public, bringing it to whatever building authority or within that city that would address this type of this topic. So I would start from there.
Yeah. Well, that's helpful. And I think, just to, to close, that is actually there's a group of us that we call ourselves the Blockheads, and this is what we're doing. And every week there's someone who is, trying to reach out to a city official, and we've had some success at that so far. Carrie, is it fair when I send out the email with the link, is the best thing to do if someone gets a hook in a city official to kind of send them directly your way?
Absolutely.
Or to the conversation?
Yep, absolutely. You can send them on to myself to me at ACI. We also, for anybody looking at referencing or adopting or using this code in some type of guidance, we allow a complimentary copy. So if you want, if any of you are working with a jurisdiction and they would actually like to see the language of it, I can provide a complimentary copy for that jurisdiction to look at. Because obviously their folks want to see it. They want to see what the language is and how it might fit into their ordinance or their codes. And that can be, I'll give you the link, Chris, and you can to where they can email me and get that information if they want a complimentary copy of the code.
Yeah, send that to me, and I'll probably send that out on Monday, since tomorrow's Friday. I have to do some film editing. I'll send that out, and people can use that as to share, I guess, with the context that they make. Well, folks, in spite of a little bit of a bumpy ride there as we got into the discussion, hopefully this was very useful for people. Matt, that was an excellent discussion, and Carrie, really appreciate the context and guidance. Bummer Brian was having some phone issues on top of the gremlin that struck. But we will send out an email. We did have a pretty large number of people that RSVP'd for that. So what we intended with today was to be able to kind of identify who those folks were. And we will be in touch with an email and can continue that discussion. But Kerry, Matt, really appreciate it. Judy, thanks for the co-piloting. And hopefully next time we won't have such weirdness.
Thank you. And everybody here that's been working on this, keep up the good work.
Thanks, Matt. Appreciate it.
Well,
Thank you, everyone.
we're going to get